welcome to one and all to the fourth session of metallurgy of welded joints. So let us start with atomic bonds. Atomic bonds are classified into two types, primary bond and secondary bond. So these are the two types of atomic bonds. So let us see what is primary bonds. A primary bond is an interactive interatomic bond in which electrostatic force holds the atom together, and these bonds are stronger and more stable in nature. What are these bonds? These bonds are interactive, interatomic. As I said, for any bonding process, bonding is nothing but a joining process. For any joining process of an atom, the atoms are joined together or are bonded together by its intermolecular forces. In the last class I said it is joined together by intermolecular process. This joining is known as a bonding. So a primary bond is a interactive, means the atoms are going to interact with each other. These interatomic bonds in which electrostatic force holds it. In this, electrostatic forces are there to hold the atom together. These bonds are stronger. When you compare with the secondary bond or any different types of bonds, these bonds are very stronger. So this is most suitable, we find it in metals. That is why the metals are stronger in nature and more stable. What is stable? Any material which will not dissolve. Very simple, I can say. Sugar will dissolve, salt will dissolve, but the stable means it will not dissolve. It will not dissolve. That is why it is called more stable, and it can withstand very high temperature. In this word I can say it can withstand high temperatures compared to any other material. So the primary bonds is a interactive interatomic bonds in which electrostatic forces are there to hold the atom together, and hence these bonds are stronger and more stable. There are different types of primary bond. First one is ionic bond, second one is covalent bond, third one is metallic bond. So these are the different types of bond, primary bonds that we are going to see. So next you can see what is known as ionic bond. So in this sketch you can see there is a sodium and a chloride. I have taken sodium chloride NaCl as an example of a salt which is being used. So this is a sodium, this is a chloride. So when you combine these two, when this bonding takes place in these two, we will call it as sodium chloride. And here you can see there is a atom movements. As I said, basically there is an atom. In atom, ions movement takes place. The outermost will be an electron which are negatively charged. The innermost will have positive protons and neutrons, neutrally charged, both known as nucleus. So here you can see the sharing of atom takes place only at the outsides. Some theories have been explained how the atomic structures are bonded. There are various theories. In some theories, they explain about the atomic structures or how the atomic structures are bonded. In this figure, you can see one such theory which describes a ionic bond. This is one such theory which describes what is ionic bond. Ionic bond is a bond that consists of many gases or liquid. You know there are three phases of matter or three phases of any material. We will call it as solid, liquid and gases. So here ionic bond is a bond that consists of many gases and liquids. So it consists of many gases and liquids. In this bond, as I said, the valence electron in the outermost shell is attracted to the elements whose outer shell has minus. What is minus? It is a negatively charged. Negatively charged means it is an electron. So in this bond, the valence electron in the outer shell is attracted to the elements whose outer shell has minus, means the sign is negative. So as I said, the sharing of electrons takes place only at the electrons will share. No, protons and neutrons will not share. The valence electrons balances the two shell which they are placed when they are placed close proximity. How these valence electrons will move? When they are placed very close to each other, what happens? The electrons balances the two shell. So during sharing, it should ensure that both the atoms are well balanced. So once the balancing is done, so this bond is known as ionic bond. What did you understand in ionic bond? Ionic bond is formed by gases and liquids. So the sharing of electrons takes place only at the outermost orbit, which is known as valence electrons, which the outer shell has negative charge. They will share each other, and while sharing, it should ensure that number of electrons in an atom should be well balanced. There should not be any imbalance. How does this valence electron shares? When both the atoms are brought closer proximity, closer to each other, immediately the outermost orbit starts movement, bonding takes place, and then both combined together we will get an ionic bond. NaCl, sodium chloride, is a very good example for ionic bond. Let us see what is known as covalent bond. So in this sketch you can see there is a two hydrogen atom. So you know very good example for this is H2O, water. In H2 is a hydrogen. It consists of two hydrogen atom. I used to take an example of hydrogen atom everywhere. Why? Because in the first session also I said hydrogen is a very light atom. We are going to take this as a reference. Okay, so even though it is comes under a metalloids characteristics, but we consider it as non-metallic. In the first session I said very clearly it comes under non-metallic. So we have taken covalent bond in this two hydrogen atom, one hydrogen atom, one hydrogen. You can see the sharing is shown in a blue color, how the electrons are shared at these things, how two hydrogen atoms are bonded together to form a covalent bond, that is H2. So here in the figure shows a covalent bond. A covalent bond is the bond in which electrons are shared in the outer shell. Here also the electrons is shared in the outer shell. The sharing that completes the number of electrons in each individual shell. When does the sharing completes? When number of electrons in each individual cell. When the number of electrons are there, they are going to completely fuse together. Then it is called as a sharing. A covalent bond is drawn because of attraction of tight in the force of these shared electrons. So as you saw that atomic bonds, by primary bonds, basically it is due to electrostatic force. Similarly, this tight force is known as electrostatic force. These electrostatic forces will involve so that the electrons are shared uniformly between the bonds. So this type of bond is covalent bond. We saw in a primary bond, ionic bond we saw, this is a covalent bond. In ionic bond, electrons will share and electrons will share so that the atom should be balanced. In a covalent, so here the bonds, atoms, the electrons are shared due to the tight force that is caused in the covalent bond. I hope you understand what is covalent bond and what is known as atomic bond. So next we can see what is known as metallic bonds. What is metallic bonds? The metallic bonds, in this sketch you can see the red color, a small red color indicates a free electrons of the outer shell of the metal atoms. Outer shell of the metal atoms. These positively charged are known as metal ions. So you can see here there is a metal ions. In between that you can find a free moving electrons. Metallic bond, third type of bond is primary bond. Third type of primary bond is metallic bond. A metallic bond is a bond in which atoms within the metals are bonded. What is this in this? Atoms within the metals are bonded. It is not formed by gas, it is not formed by liquid, but here atoms within the metals are bonded. In metallic bond may be negatively charged electrons. In this there is a negatively charged electrons clouded, completely surrounded by positively charged metal ions. It is, if you see here, the red one, the small red one is a negatively charged electrons, completely clouded. It is completely clouded, surrounded by positively charged metal ions. Positively charged metal ions, surrounded by positively charged metal ions. Next is, these electrons clouds is composed entirely the valence electrons known as metallic elements. So here also the valence electrons are completely freely moved so that the bond is formed. So these type of valence electrons is known as metallic elements, and this type of bond is metallic bond. So this all the three comes under a classification of primary bond. So I hope there are three types of primary bond: ionic bond, covalent bond, and metallic bond. So this you are supposed to explain this when the types of bonds are asked. Next is known as what is secondary bonds. So primary bonds are strong and stable. Let us see what is secondary bonds here then. Secondary bond is a intermolecular bond. There it is a static force. There is a static force is required to bond. But here it is a intermolecular bond in which weak forces holds the molecule together. There is a strong forces, but here it is a weak forces. The difference between the primary and the secondary bonds is there the bonding is strong, but here the bonding is involved by weak forces. So these weak forces are known as van der Waals force. Dear students, these forces are known as van der Waals force. The secondary bond is an intermolecular bond in which weak forces holds the molecules together, and these weak forces are known as van der Waals force. So these van der Waals weak forces holds the atom together, the ions together to form a bond. So I hope secondary bonds are the weakest bond when compared to any other type of bonds. So what is van der Waals force? Here you can see there is a negative electrons. So there is a, here you go, electrons. The van der Waals force is shown in a figure. The van der Waals force is a weakest attraction force that is caused by the separation of electrons from the nucleus. What is this? When these forces are formed, these forces are attractive force that is caused by separation of electrons. During the separation of electrons from the nucleus, these type of forces are there. These forces are weaker in nature. These weak force we will call it as van der Waals force. The electrons often interchange inert gas from one nucleus to the another nucleus. So as I said, if you see the figure here, there is a one atom, there is another atom here. Between their center you can see two nucleus are there. So the electrons often interchange inert gas. There is an inert gas from one nucleus to the another nucleus. So this is known as van der Waals force. So this is about a secondary force. One thing we understood in a atomic bonds, primary bonds are strongest and stable bonds, whereas a secondary bonds is a weakest bonds. These forces, weak forces, are known as van der Waals force. So these forces are caused by the separation of atoms from the nucleus. So dear students, let us test the next topic known as space lattice. What is space lattice? A metal in a liquid state or amorphic are said to be non-crystalline structure. So as you said, any crystalline material, any crystal should be a solid. Crystal is nothing but a solid. This solid should be crystalline in nature. What is crystalline? The atom should be arranged in a polyhedral shape and size, in a regular pattern. It may be square, it may be triangle, it may be rectangle. The order should be perfect, it should be regular. Regular means all the atoms should be packed perfectly. Whereas a metal in a liquid state, when you heat the metal, it comes to the melting point. At this, once it catches the melting point, it will form a liquid. This liquid state are known as amorphic. What is amorphic? Amorphic means it is having a characteristics of non-crystalline structure. So during non-crystalline structure, what happens? The metal will freely flow. The metal will freely flow. So when the free moving electrons within a molten metal begins to freeze or solidify, now what happens? You have heated the metal. Now we are cooling it. During the cooling process, what happens? There is a loss of heat. Heat will be removed away. When from liquid to solid, when you want to convert from liquid to solid, you are going to cool. Whereas if you convert from solid to liquid, you have to heat. So here in this process, we are going to cool, freeze. So freezing. Once you cool, what happens? The liquid metal, wherever the crystal structure atoms are there, so the free moving atoms within the molten metal begins to freeze. At that place itself, it becomes a solid. So when the free moving atoms within the molten metal begins to freeze or solidify, means it is going to cool. It is going to become solid, from liquid state to solid. This process is known as solidification. The process of converting liquid to solid. What you will do? We will cool. So this is known as solidification. So they attach themselves to each other in an orderly, well-defined system which is called as space lattice system. What is space lattice system? That's what we are explaining now. So when the metal is in liquid state, it is converting into solid state by cooling. What happens? By cooling, we are going to make a shape in such a way that the atoms are well defined. The atoms are going to be well defined order. Such type of systems will be known as space lattice system. I hope you understood what is space lattice system. The space lattice system is a system in which the liquid metal will be cooled to the solid metal. So this process is known as solidification. During solidification, the atom themselves to each other will bond together in an orderly, well-defined system. This is known as space lattice system. In the starting this session, we have explained. In the second session, we explained about different types of crystal structure. So different here in this you can see the space lattice system in which metal crystalline usually arrange themselves are classified into 4 types. One is simple centered cubic. Next one is body centered cubic. Next is face centered cubic. Next is hexagonally closed packed. In a short form, you will call it as simple centered cubic as SCC, body centered cubic as BCC, face centered cubic as FCC, hexagonal closed packed as HCP. In a simple words, in a common language, if you want to understand what do you mean, which structure will have BCC and FCC means. When the metal in a solid state, ಒಂದು metal ಯಾವಾಗ ಅದು ಸಾಲಿಡ್ ಸ್ಟೇಟಲ್ಲಿ ಇರುತ್ತೆ ಅದು BCC ಸ್ಟ್ರಕ್ಚರಲ್ಲಿ ಇರುತ್ತೆ. ವೆನ್ ಯು ಹೀಟ್ ದಿ ಮೆಟಲ್ ವಾಟ್ ಹ್ಯಾಪನ್ಸ್ ಇಟ್ ಸ್ಟಾರ್ಟ್ಸ್ ಕನ್ವರ್ಟಿಂಗ್ ಫ್ರಮ್ ಸಾಲಿಡ್ ಟು ಲಿಕ್ವಿಡ್. ಹೀಟ್ ಮಾಡ್ತಾ ಮೆಲ್ಟಿಂಗ್ ಪಾಯಿಂಟ್ಗಿನ ಜಾಸ್ತಿ ಆದಾಗ ವೆನ್ ಇಟ್ ಕ್ರಾಸಸ್ ಅಬೋವ್ ಮೆಲ್ಟಿಂಗ್ ಪಾಯಿಂಟ್ ಇಟ್ಸ್ ಕನ್ವರ್ಟ್ಸ್ ಇನ್ ಟು ಲಿಕ್ವಿಡ್. ವೆನ್ ಇಟ್ ಕನ್ವರ್ಟ್ಸ್ ಇನ್ ಟು ಲಿಕ್ವಿಡ್ that phase we will call it as face centered cubic. Usually above melting point the liquid structure will be just like face centered cubic in a red hot condition. I can call it as a red hot condition. It will be FCC. Once again when you cool it back, just like space lattice structure, it comes back to BCC, body centered cubic. Metal in a cold state will have BCC structure, metal in a hot condition will have FCC structure. When you cool it back, it comes back to BCC. So these are the different types of space lattice system. I hope you understood what is mean by space lattice system. So in this class we discussed about what are atomic bonds, what are primary bonds, what are secondary bonds. Next, what is space lattice? You understood what is the word called amorphic. Amorphic means non-crystalline nature. This exists in liquid, whereas a crystalline structure exists in solids. When you cool it, it comes back to the solid state, that will have crystalline structure. So let us go with the multiple choice question of this session. The atomic bonds are classified into dash types: A, 2, B, 3, C, 4, D, 5. As you know, there are two types of atomic bonds. One is primary and secondary bonds. The answer is option A, 2. Second one, dash is the interatomic bond in which electrostatic force holds the atoms together. So in the class session I had explained which kind of bonds are these, whether it is a primary bond, secondary bond, surface bond or a volume bond. It is a primary bond. Primary bond is a interactive interatomic bond. So first answer. The second question, the answer is option A, primary. Which of these bond is a type of primary bond? In this out of 4, which are primary bonds in this? Which is primary bond we can consider? Surface, line, ionic, volume. So this is, the first type of bond we known as ionic bond. So these ionic bonds are formed by the liquids and gases. Okay. So the answer is C. So this ionic bond is a kind of a primary bond. Next is fourth question. In which bond? A bond in which electrons are shared in the outer shell. Electrons are shared in the outer shell. It is a secondary, covalent, volume or surface. In this answer B, covalent bond is the right answer, because the electrons are shared in the outer shell. Fifth one, in dash bond, atoms within the metals are bonded. In dash bond, atoms within the metals are bonded. It's a volume, secondary, surface or metallic. It's a metallic bond. So there is a third type of primary bond, that is a metallic bond in which atoms within the metals are bonded. Look up into the sixth question. Van der Waals force is a type of dash bond. So Van der Waals force, you know that it is a kind of a weaker force. These weaker forces are formed in type of secondary bond. So the first option A is primary, B is secondary, C is ionic, D is a covalent. So in this option B is secondary bond is the right answer, whereas A, C and D are kind of primary only. B, C and D are kind of primary bonds. So next is known as what is seventh question. Metals in a solid state will have dash structure. This is very important. As I said, that is known as a BCC structure. This being BCC structure, the metals are in crystalline structure. The atoms are perfectly periodic. Their arrangement are perfect, regular. So the crystalline structure. Metals in a solid state have crystalline structure, and option A is the right answer, crystalline. Metals in, and eighth question, metals in a solid state will have dash structure. Metals in a solid state will have dash structure. So dear students, so once again here it should, instead of solid, you take this as liquid. So if you take metal in a liquid state, you can say metal in a liquid state. Metal in a liquid state will have dash structure. What type of structure it will have? It is a crystalline, non-crystalline, ionic or a covalent. Now it is a right. Means metal in a liquid state will have dash structure, non-crystalline structure. Metal in a solid will have crystalline structure. Metal in a liquid state will have non-crystalline structure. Now it's a right. So the question answer for question 8 is non-crystalline structure. I hope you understood the difference between crystalline now and non-crystalline. Next is ninth. Metal crystalline structure which arrange themselves in an orderly, well-defined system is known as what? That is known as space lattice system. So you understood what it is. So any metal crystal, they arrange themselves while solidification process. This system is known as space lattice system. So answer is option C, space lattice system. Whereas A is a primary, B is a secondary, C is a primary lattice system, D is covalent. So option is C, primary space lattice system. Last question, 10th one. An intermolecular bond in which the weaker forces can hold the atom together. So the weaker forces will hold the atom together. So this type of bond, what type of bond we will call this? What is a primary, secondary, or a space lattice system, or a covalent bond? Which is the answer for the students? It is a weakest bond. This type of bond, the bond is formed by the weakest forces. What would be the answer? Whether it is a primary, secondary, space lattice, or covalent. Which is the answer for that? It is a secondary bond. So you come to know that the answer is B. Weakest force means it should be what? Secondary bond only. So I understood what exactly it is. So I think so you understood what is mean by atomic bonds, primary bonds, second bonds, and space lattice. Dear students, thanks for your patience listening. Thank you so much for your cooperation. Thank you, one and all.